Hello students, hope you're following the previous videos, right? Today we are going to do again one more interesting phenomena that is called as dispersion, right? So let us see what is dispersion. Right. So in order to first of all understand what do we mean by dispersion, we need to understand what are first of all EM waves or electromagnetic waves. Right. See, electromagnetic waves, there are many electromagnetic waves, right? Out of those electromagnetic waves, there is only a small part of these waves which is visible to us. Okay. Human beings can see only certain specific type of light. Other type of light is not visible to us, right? So if you have some idea regarding the wave theory, this we had done in our ninth standard regarding sound waves. We know what do we mean by wavelength. So distance between the start of the wave to the end of the wave, this is called as wavelength, right? A wavelength is denoted by lambda symbol, or you can also say distance between two consecutive crests or two consecutive troughs, right? This is called as wavelength. Now we can see waves, okay? We can see waves which has a wavelength of 400 nanometer. Okay, nanometer, that means 400 into 10 to the power minus 9, right, meters, to 700 to 750 nanometer. Okay, 700 nanometers, so that is 700 into 10 to the power minus 9 meters. So those waves, those electromagnetic waves which has a wavelength of this range, that is from 400 to 700 nanometer, we can see those light rays. So the light rays which fall between this range, 400 to 700 nanometer, this is called as your visible range. Visible range. When we go to higher grades, we will do electromagnetic waves in detail, each and every type of wave. Like for if you see this, like this is called as electromagnetic spectrum, right? There are 7 types of waves which will come under electromagnetic spectrum. So the first one, it will start with radio waves, then you have microwaves, infrared radiation, then comes visible light. Then after visible light, you have ultraviolet, X-rays and gamma rays. Gamma rays have the smallest wavelength and radio waves has the highest wavelength. So if you see the scale, this is the scale is for wavelength, right? Radio waves are the highest wavelength. Okay. So out of these 7 types of electromagnetic waves, only this range is visible to us, 10 to the power, right? Only this range is visible to us. Electromagnetic radiations refers to the waves of electromagnetic field propagating through space carrying electromagnetic radiant energy. We are going to do this in detail in our higher grades 11th and 12th. No need to, take tension for this, that we don't know how are we going to do it, right? So just remember, visible light, which we see, is a type of electromagnetic wave, and we can see only a certain type of waves is visible to us, which has a wavelength of 400 to 700 nanometer. Okay. Now, in order to study dispersion of light, we also need to first know what do we mean by white light, right? White light is, so this is a visible range, that is 700 nanometer to 400 nanometer. So obviously then comes 500, then comes 600, then comes 700. So in this visible range, our visible range is basically made up of 7 colors. 7 colors of light. So it starts with violet, indigo, blue, green, yellow, orange, and red. Right? So this is your Vibgyor, we know, right? Short form of Vibgyor. So these are different types of 7 colors which makes our visible spectrum. Violet light has the least wavelength, which is 400 nanometer. Okay, violet light has the least wavelength, 400 nanometer. Red light, on the contrary, red light has the highest wavelength, which is 700 nanometer. Okay. Now, when you see this, okay, when you see this, when all these 7 colors come together, Okay, all these seven colors come together. They make what do we call as white light. Mixture of all these seven colors, right? So you can consider a mixture of all these seven colors of light. Each color has a different wavelength. That means this mixture will contain waves of seven different wavelengths, right? Seven different wavelengths. So it is a mixture of seven colors. So mixture of these seven colors, which is visible to us, is called as white light. Okay, right. Now, what are the sources of white light? From where do we get white light? Right, we can see each and everything in the world, right? So what is the source of this white light? The source of white light is basically sunlight. Whatever light is coming from the sun is basically white light. Then also your bulb, right? Tube lights, LEDs, all these sources of light which emit light of this particular wavelength, all these are sources of white light. Now we come to what do we mean by dispersion, basically the phenomena of dispersion. Understand, when a ray of white light, so this is your ray of white light, this ray of white light is going like this. Okay, so when a ray of white light enters a prism, this is a prism. Okay, do you know what is a prism? A prism is nothing but two triangular faces connected to each other by three rectangular faces, right? So this is your face one, this is your front face, this is your back face, and these are called as edge pieces, and this is your base. So I'll just try to, so this is base, edge one, edge two, and this rectangle which you can see over here, the front one, this is the front rectangle, and the back one is the back rectangle. So this is basically is a prism. Prism can be made up of glass, prism can be made up of optic fiber. Okay, it is basically a transparent thing, right? So when a ray of white light passes through a prism, this is the ray of white light which is passing through the prism. When this ray of white light passes through the prism, we know what is white light. White light is a mixture of seven colors. When it passes through the prism, it gets splitted up. You can see over here, see, all these seven colors are getting split into its seven component colors, seven components, right? So this phenomena, basically the splitting of white light into its seven component colors, is called as dispersion, right? There is one beam of white light over here. This is this one beam of white light which is passing through the prism. When it passes through the prism, what happens? All these seven colors are split into different bands, and when it goes outside over here also, it is again getting splitted into its band of colors. So this entire phenomena which is happening over here is called as dispersion of light. Okay, so what is dispersion? Dispersion is basically splitting of white light into its component colors is called as dispersion. And the band of seven colors which we are getting over here. Okay, so if you see, we get these band of seven colors. So if you had observed this, see, this is the first one is the red color, and the last one is the violet color. Okay, we'll see why violet is the most bended and why red is the least bended. We are going to see that. So now this band of seven colors is called as spectrum. Okay, now what is dispersion of light? We just saw. So if a question comes, define dispersion of light. Okay, you will have to write the phenomena of splitting of white light into its constituent colors is called as dispersion of light. Phenomena of splitting of white light into its constituent colors is called as dispersion. The band of colored component of light beam is called as spectrum of colors. So if you can see this band of 7 colors over here, this band of 7 colors is called as spectrum of colors, right? Okay. So this is the experimental arrangement when we had to study dispersion of light through a glass prism. So if you observe, this is the source of white light, a bulb. Many rays are coming out of from this bulb, right? But then we have kept a cardboard over here, a wooden board over here, and the small slit is over here. Why is this arrangement done? Because we only want one ray of light, right? So all these rays are obstructed by this wooden plank, and through this small slit only one ray of light can pass through. Now this ray of light enters the prism. Through the prism it is getting dispersed into its component colors, and then a screen is kept over here. On the screen we will be able to see the band of these 7 colors, so red to violet. This is your spectrum of colors. This is the experimental arrangement to study dispersion of light, right? So a prism is placed in a room and a narrow beam of white light is allowed to fall on one of its refracting surfaces. Now again, as we saw reflection, refraction, what was refraction? Refraction was happened when the ray of light is passing from one medium to another. Now this ray of white light is an air medium. Now this is a glass prism, so this is a glass medium. So what is happening over here? Two phenomena is taking place. One is your refraction because change of medium is taking place. Another is your dispersion, right? Okay. This is the band of colors: red, orange, yellow, violet, indigo, blue, green. So a small phenomena or the small mnemonic you can use over here, it is basically Webcure. Webcure, right? Spectrum of colors. Again, as we saw, if you now, this is just the same thing which is being repeated. So this is one single beam of white light. It is getting split over here. Okay. And if you see, the violet light is at the end and the red light is over here, the first band. And if you see the bending, right, if you see the bending, violet has bended the most, because if you see, if there was no dispersion of light which was taking place, the ray of light would have just gone like this. It would have just gone like this. Okay. If you observe carefully, from this particular direction, the ray of light has now gone from here to here. Okay. So that means the violet light has bended the most. Why is the bending most for violet light, and why it is the least for red light? Okay, that I'm going to tell you. Okay, just keep it in mind. Red light has a wavelength of 750 nanometer and violet light has a wavelength of 400 nanometer. Now, what causes dispersion? Why is dispersion happening, or why is one ray of white light getting split into its component colors? So this is dependent basically upon the speed of light. Okay, all the electromagnetic waves travel in vacuum with the same speed of light, that is 3 into 10 to the power 8 meter per second, all the entire electromagnetic waves. But now we don't have to consider the entire EM spectrum, we are only considering the visible spectrum. So visible spectrum is from 400 nanometer to 700 to 750 nanometers. Some textbooks say it is 700, some textbooks say it is 750 nanometers, right? Now, these rays of light, when they travel in air or vacuum, they travel with the speed of 3 into 10 to the power 8 meter per second. Okay, the velocity does not change. Though the wavelength is changing, velocity is not changing. So this is like violet, indigo, blue, green. Violet starts with 400. This will increase, and red goes to 700 nanometer. Right? That means your lambda is increasing. Now, when lambda increases, frequency decreases. Okay, because there is one very important formula that we have, that velocity is equal to frequency into lambda. Okay, velocity is always equal to velocity of ray of light. Remember this. This is going to be helpful to you in your higher classes as well. Velocity of light is always equal to frequency of that light into wavelength of light. As the velocity is constant, things has to take place over here only, because wavelength is changing. We know wavelength of light is changing, so frequency also changes. So if frequency increases, lambda decreases, and vice versa. If frequency decreases, lambda increases. So in the Vibgyor section, we know as lambda is increasing in this way, frequency will decrease in this way, right? It will increase from, so violet light will who has the least wavelength, frequency will be the maximum, you can see over here, and red light, which has the highest wavelength, frequency would be minimum. Okay, see this. 4.84, 10 to the power 14. This is in the range of 10 to the power 14. Now, light of different colors, due to their different speeds and glads, gets deviated through different angles towards the base of the prism. This is very important, because this tells us why the red light is getting the least bended and violet light is getting the most bended. Right? So it says that light of different colors, we know there are 7 colors, all the 7 colors of light have different wavelength. Okay, now again, these questions we are doing. Velocity is equal, what is the general formula for velocity? Velocity is equal to distance upon time. Okay, now when you consider red light, the wavelength is the highest, that is 700 nanometer. Okay, so this wavelength is considered as distance traveled. So obviously the red light is traveling more distance, because it has a wavelength of higher than the violet light. Okay, now as compared to violet light has 400 nanometer. Okay, so this is again that this can be compared to distance traveled. So the wavelength is like this. Understood? Now, when this enters the glass prism, when this white light enters the glass prism, okay, this white light is a mixture of 7 colors. Each type of color, according to its wavelength, right? All the 7 colors have different wavelength. So according to their respective wavelength, the speeds will increase or decrease. Okay. Now, when you say red light has a highest wavelength. So if it has a highest wavelength, that means distance traveled by red light is the most. As distance traveled by red light is most, velocity of the red light is also maximum. Now, if the velocity of the red light is maximum, that means without much deviation, it can just go through it can just pass to the next this edge without much deviation. As the velocity of red light is more, it will go, or it will hit the second surface very easily, and then again come back as well. Okay, like this. On the contrary, the violet light has least wavelength. So due to its least wavelength, that means it is not traveling much of a distance. Distance traveled by violet light is less. So hence the velocity of violet light is also less. As the velocity is less, that means the violet light is traveling slowly. Violet light is traveling slowly through the prism, and as it is traveling slowly, in this process, it is getting bended as well. Right? It is also getting bended, because the velocity is slow. So this bending, as the velocity is less, more bending will be there. Velocity more, less bending will be there. You just need to remember, if the question comes, as red light has more wavelength, velocity will be more, hence bending would be less. On the contrary, violet light wavelength is less, hence velocity will also be less, therefore bending will be more. So you can just explain this in 3 to 4 points. Draw a prism, show the dispersion of light through prism. Okay, and give these reasonings, right? I hope things are clear till now. Okay, so now if dispersion is clear with you, we have one more phenomenon that is called as recombination. Okay, principle of recombination of prism. Now this entire experiment was done by Newton. Newton thought that, okay, if I am passing one beam of white light through the prism, it is getting split into 7 different colors. Now, if I place one more prism in front of this particular prism, I place another prism, prism 2, and when these band of 7 colors hit this prism, I might get another more 14 to 15 colors. Okay, these 7 colors will split into again more component colors, and more number of colors I will get. Okay, this was his thinking, but which did not happen. Okay, so the band of 7 colors which passed through the prism remained the band of 7 colors itself. It did not uh, got into 14 or 20 colors. He did not get, he got only a band of 7 colors. So he tried to change the orientation of the second prism. First he kept it like this, then he kept it in this way, and then he kept it in a reverse position like this. Okay, to his surprise, when he kept the prism in an inverted position, right? So it is this way. When he kept this prism in an inverted position, and when this band of 7 colors hit the prism 2, when it came out, right? When it came out from the prism 2, it again got converted into one single beam of white light. That means all the rays, okay, all the ray of light, which all the 7 different colors which were hitting the surface of the prism 2, they got recombined together, and they again formed one single beam of white light. So when one single beam of white light is entering, it is getting dispersed, and when this dispersed spectrum of band of 7 colors hitting another prism, it again gets recombined into one beam of single white light. Right? So this entire principle is called as principle of recombination, okay, discovered by Newton. So a question can come, or mostly a question comes as in show the diagram or explain the phenomena of recombination of white light done by Newton. So you can draw this diagram. It says one ray of white light is getting splitted up. All these 7 band of colors is hitting the second surface of the prism. It is again getting recombined. So the recombination is happening at the prism 2, and again we get one ray of white light. And if we place a screen, we will only get one dot. Okay, if this would have been a spectrum, we would have got a band of 7 colors. But this, to our expectation, against our expectation, we only get one single beam of white light. That means what is happening? This entire 7 colors are getting recombined together and again forming into one single ray of white light. Understood? Okay. One more important thing that we have regarding the prism, this normally comes for CBSE students, regarding the angle of deviation, or this particular diagram is very, very important. So if you see a prism is like this. Normally in the prism, this angle is called as the angle of prism. Okay, it can be 45, it can be 60, depending on what orientation your prism is. So this is a 60-degree angle of prism, right? Now, consider this is the beam of one ray of light which is passing through the prism. Okay, this is the beam of light. Now, obviously, at the point of incidence, what are we drawing? At the point of incidence, we are drawing this normal. So this is my angle of incidence. Now, as it is going from a rarer medium to a denser medium, it will bend towards the normal. So this is your refracted ray. Again, this is the point of incidence. We draw a normal over here again. And now it is going from a denser medium to rarer medium. So it will move away from the normal. So now the angle which is formed over here with the normal and this emergent ray, this is your angle of emergence, angle of incidence, right? Now, one thing we have over here, so this is your incident ray, refracted ray, and emergent ray. Okay. Now, if you extend your emergent ray in this way and your incident ray in this way, the angle formed by the incident ray and the emergent ray over here, this is called as angle of deviation. So if you see this yellow colored angle, This is your angle of deviations. Normally come for the CBSE board examinations to draw this entire diagram. Okay, so draw a diagram of prism and a label angle of deviation over here. So what you do, nothing, it's easy. Normally students get confused for this angle of deviation. So just take an incident ray. This is the refracted ray. Make the refracted ray parallel to the base of the prism. Then just bend it forward again. This is your emergent ray. Take your incident ray like this. Take your emergent ray behind, right? And the angle which is formed by the incident ray and the emergent ray, this angle is called as angle of deviation, right? This is your angle of deviation. Okay. Right. Next class we have the formation of rainbow. So now the formation of rainbow is entirely dependent upon the phenomena of dispersion, because rainbow is basically, what do we see in a rainbow? We see a band of 7 colors in a rainbow. So this is entirely dependent upon the phenomena of dispersion. Right. Hope you understood the concept. Stay tuned. Again, many more interesting episodes to come. Thank you. See you. Bye bye.